my name's Thanom and I'm from UNSW. Today I'm working through some of the Math 1011 calculus problems from the section on modelling with the exponential function. So question 8 is about carbon-14 dating. So we have to know that carbon-14 obeys an exponential decay law. So we can calculate the number of carbon-14 atoms T years after a tree has died, and that's equal to an exponential function here. A is the initial amount of carbon-14 atoms, and K here is our decay rate. T is time, and here it's going to be time in years after the tree has died. So we're given the half-life of carbon-14, and we want to know how old the artifact is if it contains 40% as much carbon-14 as a living tree. So let's use the information that we've got to calculate some constants. So first of all, given the half-life is 5,730 years. So that means it takes 5,730 years for half as much to be left. So if we know initially there's a carbon-14 atoms, so when T equals 0, N equals A, then there's half as much left when N equals A on 2. So half as much left. A on 2 equals A e to the minus K times 5,730. So when T equals 5,730, there's A on 2 carbon-14 atoms left there. So there's A's on both sides here, so I can divide both sides by A. So this tells us that a half is e to the minus K, or let's write it as minus 5,730k, and if I take logarithms of both sides, that tells us that the logarithm of a half, the logarithm of e to the power of minus 5,730k is minus 5,730k. So I can divide by minus 5,730 there, but before that I might just write log of a half as minus log 2. A half is 2 to the minus 1, so I can bring that minus 1 down here. And so then I'm going to write k as just the logarithm of 2 divided by 5,730. Okay, so I know this is my decay rate here. Okay, now the question is asking us how old the artifact is, find the age of the artifact, and we know that the artifact contains 40% as much carbon. So we want to know, so we wish to find T when there's 40% as much left. So when there's 40% of A left, so when N equals 0.4 A, so 0.4 A equals AE to the minus, this is K here, ln2 on 5,730 T. And so we want to solve that for T. So there's 40% left, and we wish to find the time. So here 0.4 is e to the minus ln2 on 5,730 T. If we take logarithms of both sides, the logarithm of e to the power of that is just minus log 2 on 5,730. And so T is just going to be 5,730 times log of 0.4, all divided by minus log of 2 there. I can put that in my calculator. And I get, let's say, approximately 7,575 years. I'm rounding that to the nearest year there. Okay, so we know there's half as much left after 5,730 years, so it makes sense that there could be 40% as much left after 7,575 years. So that's the age of the artifact there.